Hi, everybody. Thank you for joining us today. Welcome, Ottawa Drupal community, to single directory components plus web components equals mind blown. And on the agenda today, we have a brief introduction, component-based development process, single directory components, workflow overview for component-based workflow, and then we'll get into some more in-depth about what makes a web component, and then we'll discuss shoelace web components in Drupal, and then evolving Drupal for web components. And my name is Matt Hand. I'm a senior software engineer. I'm here representing myself today. I do have a day job, but it's really difficult to get slides approved in less than 30 days. So I am drawing from real life experience in what we're talking about today. And Robert's going to take us away.
Hello, my name is Robert Ngo. I'm currently the solution architect at Evolving Web. So before we start the presentation today, I have a question, like how many of you are developer front-end and back-end? Thank you. And how many of you are product manager, product owner, and designer? Thank you, not many. So the reason that we talk about it is because, like, today we talk about the SDC and how it changed the way that we collaborate in between the PM, PO, developer inside a project. So I want to start the talk about with the component-based development. It will be a very far, and then we will get into the SDC, and then we get to the web component later. But first, about web component, about component-based development. So before, when doing teaming in Drupal, the workflow usually will be the designer who designs something and then hand it over to the developer. We do on the Drupal teaming technique, we do like templating, display mode configuration, and custom pre-process there. And then we do test it inside the Drupal environment. And then if there is something happen, we need to revise something, it's the Drupal developer who do it. Basically, this process doesn't include much of the interaction between the designer and the developer. So we call it the waterfall process. So with the new process, the new component-based development, first, component-based development is mean like everything will be packed inside a component, which is self-contained, and so that we can reuse the component in multiple places so that it will be easier to scale up. So with the new workflow, we propose that the designer can hand over the design to the developer. We build a component, we test it, but it just will be outside of the environment of Drupal. And then when doing that, we have the possibility to mock it up easily and then go back to revise it, or even when showing it to the designer before implementing to Drupal, which means the interaction can be much more efficient. And if there is anything to revise, it can happen before going into Drupal. So there is a term, quite a funny term for that, which is the hot potato process, where people just throw in the hot potato around. So for the component-based development, why do we need to do it? If we search online, there we have like many arguments stating the advantage of using web component, but from our experience, we just want to highlight a few things in here. When we implement it in our project, it's provide a much better workflow from design to code, like more interaction in between the designer, PM, EPO, and developer, better teaming structure, component versus the spaghetti component. Before we were styling, we modified the paragraph template, no template, but now everything will be self-contained in one component, and we can test that exact component in an isolate mode, which will be much efficient and reusable. Let's say if in our system we have button used in multiple places, but we just need to develop one component and reuse it everywhere. Like I said, it's just it offers a better way to test the component, and test is important in our industry. So, and the last point, I think that is the most important, which is to provide a global view on what kind of component that we have in our system. So on the screen that we see, that is a list of all the button that we developed in one of our projects. Looking at it, we see what kind of button, what are the state, how does it look like in the dark mode and in the light mode. And if we want to change anything, we need to care about the global structure, global view of the style of the button using it across the site. Or this is another example where we can have a global view on the existing banner or card used in our project, which is the OCAD, Ontario College of Art and Design. Let's say as a product owner, if we want to add a new hero, we will look into the existing library and see, should we add a new one or should we use an existing but changing some variable in there, and that should be enough or not. So we know that we want to implement component-based development, but how? And in the past, this is not, component-based development is not something new. Drupal has been implemented in the last several years using a different technique. There are people using UI pattern, there are people using a single file component, or use the base API of Drupal to automatically bootstrap and load on the CSS and JavaScript. But now we have the single directory component, which is a new thing, and it is officially published in the core from Drupal 10. And it has a simple API, easy to use, and a growing community. And now if we follow on the Drupal Slack, and there we have many implementation discussion to grow the SDC in a much more powerful tools that we can use in a much bigger project. So SDC, single directory component, the basic structure is very simple. It will need a metadata file, a twig file that define the markup, and optionally will be JavaScript and styling. So this is an example of the button component that we have. First, it's just about the metadata. So basically you can see over here, we have the, we can declare the different, like, think about the component like a black box. We don't know how it make it happen, but we just know that this is the input and it will take care of the output of the component. It will take care of the rendering of the component. So in this case, the input of this component will be the text, the URL, the icon type, and the output will be the rendering will be handled by the twig file declared in this component. So for example, in this case, it's simple as a link with the additional class that we add in there. So one more reason that we want to use a storybook is because it supports the storybook. So have you ever used a storybook before? Have you ever heard about storybook? Yeah, thank you. So storybook is like a Node.js application that used to visualize the UI component, which means we can see how the component looked like before integrating into Drupal. And it's have a big, it have many add-on that support some valuable features. For example, the accessibility testing, visual regression testing, and we can easily mock the data that we want. So this is the example of the storybook that we set up in one of our projects. And you can see that there is the accessibility. It say that this button passed the 6 criteria of the accessibility. And the way that it's worked with SDC, like before SDC, when we use the UI pattern, we need to depend on a library named twig.js that will interpret what we write in the twig file and then render it in storybook. But with SDC, it will be a different way. There is a module named CL server that will expose the component, that will render the component and expose it on the Drupal side. And then as the storybook will read that component, which means the component that we see in here, it's rendered, it go through the rendering pipeline of Drupal. It's the real Drupal component render it out. So it's much more real and easy to work with. So with that, in our project, we are proposing the new workflow for our team on how to use it. So this is our current workflow. We have the designer hand it over. The front-end developer will work on the component and test it. They don't need to touch the Drupal side. Everything will happen there. They can test how the component look like in the storybook. And then we do manual testing there, and we are trying to implement the visual regression test. Because with Storybook, there is an add-on, let's say chromatic, and then we can conduct visual regression test of that single component only. So when we do some changes, we run the test again and we see, okay, should I approve the change or not? So that will be more reliable when we evolve the system over time. So that is the workflow in a normal project. And in some bigger project, let's say we are working on an organization where we need to build like more than one site with 5 or 10 sub-sites. And the requirement is to have the branding consistency. So we would set up the SDC as a component library and put it as an upstream and then fetch it into the Drupal site using Composer. And then, which means in each children Drupal site, when we do theming, basically just clone the component from the component library. And that makes sure that the branding is consistent across multiple sites. So that is the idea of component-based development and how SDC can help to implement it in our project. Next, I will pass it to Matt to talk about the web component.
Let's give a round of applause to Robert. So again, my name is Matt Hand, senior Drupal developer. I have 15 years web development experience. I actually started as a designer, so I have about 5 years of design before that. In the last 18 months, I've been integrating a web component library with Drupal that powers many websites. And also I'm a Washington, D.C. go-go music ambassador, self-declared. And I'm wondering who in this room knows about go-go music? Okay, I'm in the right place. You're all about to learn Washington, D.C. has created a unique music genre called go-go. And it's defined by Caribbean drums and percussion like the congos. But most importantly, the biggest feature is that the audience is participating in the music. It's not just a show where the band's on stage. The audience is a part of the show. And there's a technique that's called call and response. And that's how they get the audience engaged. And I thought maybe we could practice that right now. I want you all to do this loudly, as loud as possible. If it's not loud enough, we're going to try again. But I'm going to call out. When I say D, you say C. D. D. There you go. So that's go-go music in a nutshell. If you want to talk about it later on, we can. But it is applicable to audience participation. And I wanted to lead off with a quote from Batty. She's the former chairperson of the Drupal Association. She's a CEO of 1X Internet. And they do a lot of work in web components. I was lucky enough to find myself on a Drupal trivia team with Batty, which is a significant advantage to have the president of the Drupal Association as your Drupal trivia. And we had an excellent conversation where she repeatedly said that web components really should be used in every project going forward. That's her theory. That's her premise. I'm starting to believe it myself after having used them for the last 18 months. So let's start with what makes a web component. First off, web components, they really did kind of come up with the JavaScript frameworks. They're fully native to the HTML web browser. So it's not just that the JavaScript framework creates these web components. It's created in the web browser using what's called the Web Component API. It's an established, protocol, and it doesn't depend on React. In fact, when you're using web components in React and other JavaScript frameworks, React depends on your web component library. So it kind of goes the other way around now. And it allows you to reuse these web components in any framework. We're talking Vue.js, Drupal, anywhere, because they are native to the web browser. And they essentially just are four things. It's a custom tag name, custom attributes, custom events, and then content slots. So all that makes up what is a custom HTML, element. And it does not inherit properties from other elements. So you get to choose what is, consistent, what attributes should be found, what events are going to be supported. That's all declared by the people that are developing and creating these web components. Typically, it's in a Node.js stack that they're created, and then they're leveraged throughout your enterprise. So this is just a quick sample source code. This is what I'm talking about. SL-button, that's the custom tag. The href, that's a custom attribute. It doesn't have to be there. They wanted to make sure that this would become a link. So they added the href attribute, and then behind the scenes, they make it into a link. So this is what it looks like when you look at the source of your page. This is what it looks like. However, when it renders and the browser does its business, it is outputting additional markup inside that tag for you. So it will translate the SL button to include a link. And then it also includes what's called a slot. And slots are where the content goes. So if you look, here, link styled like a button, that's our content. But then when it becomes the web component, it's actually inserted inside this slot with a class that styles it a certain way and then wrapped with the link tag. The nice thing about this is it's very repeatable patterns. You can establish something that's accessible. You can establish something that's on point with your brand, and just over and over again, it's the same exact experience. The primary features of web components, there's like 7. There's a lot of articles out there. Feel free to find them. These are the 7 main features you'll find for web components. I'm only going to talk about 3. I think those 3 are most important for our work with integrating with Drupal. That would be encapsulation, isolation, and separation. So this is what makes them different from, other, patterns of development. The encapsulation, the web components are fully self-contained and modular. That means it's the exact same component that's being used in your Drupal site, that's also being used in your web app, that's also being used in your smartphone app. It's the same code, it runs the same way, and it's very consistent that way. The encapsulation also means it's delivered in a package bundled together, and it allows then for you to reuse it across, other applications in your enterprise really easily. The other JavaScript, the style sheet, and the template are all bundled together and delivered together. All this is done in the JavaScript layer now. So you do need to have a firm understanding of JavaScript if you are going to actually write your own web components. Typically, what I find is, though, that there's some Node.js programmers that are creating these web components, and then us as like Drupal developers, our task is to then integrate them into Drupal in a way that makes sense and adds up. The isolation concept, the style rules inside these web components are protected from page assets. You're not going to get style conflicts. You won't. And using like regular single directory components, you can't actually guarantee that. If you're using a web component, this is fully isolated from the styles on the page. They will not apply inside that web component. What that allows for then is this web component looks the same on any site, regardless of what their global style sheet says. It's going to load the same way every single time. There's a lot less conflicts. The template is rendered in what they call the shadow DOM. So the shadow DOM is this kind of new concept where it is a part of the markup that gets rendered that cannot be easily accessed, cannot be easily seen. That's why they call it shadows. And in order to actually peek into there, you actually have to do a lot of effort. The web component makes it easy. The browser can see the shadow DOM, no problem. Can all of your other JavaScript see inside the shadow DOM? No. Can all of your styles see inside the shadow DOM? No. So that's the isolation. That's how it protects it from the rest of the page. That's why it's going to load the same way every time, regardless of what other styles and scripts you have loaded on that page. And then the separation, this is just a good best practice for development concepts. It's putting the correct technology to power the part of your development. So the JavaScript is doing your behaviors and your functionality. The CSS is doing the style sheets. The HTML, template is also isolated. All of these are separate, so you can have different developers working on them at the same time. It's just another advantage of using like a component-based workflow. So there's already a web component library called Shoelace. And this is an open source library. And I encourage everybody to look at it as an example of what web component libraries should be. Because this is not dedicated to a single brand, it's a very flexible library. It allows for a lot more customizations than your typical like brand powered web component library would allow for. But you can visit this link. They're on the web, and it's easy to set up, fairly easy to consume, easy to work with. I'm having a really good time with Shoelace web components, and it's a great way to get introduced to the concept of web components because it's open source. You can go look at their source code to see how they're built, and you can easily experiment with them. And then what we did, we started a module because we noticed that there weren't that many examples of Drupal integrating with web components. So because Shoelace, the web component library, is very mature, it's out there, we decided we should create a module that integrates with that. This is a module that is already on Drupal.org. It's a work in progress. It's a sample of how to use single directory components to leverage a web component library. So if you need to have an example, you can definitely go see this module and how the techniques we're using. And then over time, we're going to continue to add more features to it. It's open source, so feel free to add issues if you have a feature request, if you have a bug, if you're actually using it. There's still a lot of work left. It's only alpha right now, but definitely pay attention to it. It's going to be a really good example. If you do end up using web components in a project, we want this to be sample code for you that would be relevant for any way to any web component library. You'd be able to use these same patterns to integrate with it. So I wanted to also touch on that design system is not synonymous with a web component library. Now we're reaching a point where a lot of design systems do provide web components, but that does not mean it is, it doesn't mean that a web component library is a design system. So I think there's a lot of confusion when I've talked with this in meetings at my enterprise. So I wanted to touch on this concept. The design system, it controls your brand anywhere your brand displays. If your brand is printed on paper, your design system has documentation about that. If your brand is sending, on an email template in an email campaign, your design system has documentation about that and probably some style sheets and patterns to help you. Design systems typically provide like a browser reset and global styling for your out-of-the-box native HTML elements. I'm talking like H1 tag, H2 tag, link tag, button tag. That's what a design system would solve. They solve for the entire equation. A web component library doesn't necessarily do that. The web component library delivers web components that work great, but they're very isolated. They're not necessarily going to be the full experience. And I just wanted to make sure that, design system doesn't necessarily mean web component library and vice versa. And there's another concept too with web component libraries. You can be really strict or you could be pretty loose. And I think as developers, we're kind of used to that concept. PHP is what's considered like a loose development programming language. Object-C, that would be considered strict. What does that mean? It means you have a lot of effort to define things when in a strict environment. In a loose environment, you can make assumptions. You can get away with a lot. You have a lot more flexibility and control. So when a web component library is being designed, you want to consider, is this something that we want to be, our brand experience? We want it to be locked down. That would be a much more strict consideration. And there's ways of doing that with web components. There's ways to basically prevent anybody from modifying what is being rendered. But if you wanted to have a more loose experience, let's say you had a brand and there's sub-brands, or you have a web component library that you wanted to be more flexible and useful for a wider audience of developers. You can leverage what are CSS design tokens. CSS design tokens are ways for you to assign variables in your style sheets. Your web component library does inherit that part of CSS. So if you're using the same style tokens in your web component library, and then you provide a style sheet on your page that defines them, that is a way to change colors on your web components. If you did not use design tokens and you set a color, everybody that uses that web component cannot change that color easily. It takes a lot of effort. And I'm even talking for senior developers. I've had senior developers that finally gave up and had to have conversations with the design system and the web component team because they couldn't just hack it like they used to. So it's definitely like a lot more effort to be able to override certain pieces of these web components. There's another avenue to create more flexibility. It's called creating partitions. If you look into web components, you'll find that there's an attribute called part. When you assign that attribute called part with a name, you can actually target that element in your CSS using that part as the target, the CSS selector target. So if you want to have a web component library that is flexible, it's possible. If you want to have a web component library that's strict, that's also possible. And it's good to know like what you're actually building and expecting from the get-go. Most of the companies, big enterprises, they're going to have a very strict web component library. And my recommendation there is bring your issues back to the team creating the library. Don't try and hack it. It's going to just be wasted effort. Now we'll talk about evolving Drupal for web components. So let's do a true or false. You can just replace native HTML elements in Drupal with web components without any problems. Is that true? Show of hands. Or false? It's false. Drupal has some lessons to learn about how to support web components better. It's going to be a learning experience. And if you are involved in a project integrating web components with Drupal, expect additional effort. You will have to learn how to use these in a way that Drupal expects. So why are there special considerations then for these web components? The first thing is Drupal has all these awesome out-of-the-box features, right? Huge community of developers. However, there's one foundational assumption that they all have done, which is they assume they can always target any HTML element on the page. And when you start using web components, you can't, because those any of the elements inside the shadow DOM, they're isolated from JavaScript. They're isolated from the CSS. You can't target that. So this is what leads to some of these breakdowns. We're talking like Ajax and things like that. And the special considerations are mainly related to, the biggest one I think is functional JavaScript tests do not currently support shadow root at all. So shadow root is basically synonymous with shadow DOM, but these functional JavaScript tests, let's say you have a test that expects to be able to click a link. and you replace that link with a web component, that test will now fail. It will, even though there is a link tag inside that web component, your functional JavaScript test can't see it. It can't select it because it's inside that shadow root. There are methods in order to fix that. We'll get into that in a second. The other big piece that breaks down, it's Drupal core states visibility, better known as like web form conditions. I don't know if anybody's familiar with the web form module. You're able to create conditions where I check a box and then a new portion of the form displays. And before that, it was hidden. That's that visibility states. Drupal has amazing support for that. It's very easy for even non-programmers to build complex experiences and web forms because of that. What happens when you decide, oh, I want my checkbox to be a web component? It stops working. It will never be able to show out of the box based on clicking it. It still works in the browser. You can actually still submit the form, and the HTML browser, it works just like it always used to, as long as you have the right name and everything. But in terms of the companion JavaScript that Drupal ships with, it no longer works. Same thing goes for Ajax. Let's say you have a pager, right? You have a views pager, works great. You want to use a web component pager. It will work great as long as you're not using Ajax. But when you enable Ajax in Drupal, it stops working. It loses that connection to the events that Drupal is listening for, and that's why it breaks. Also, jQuery support for shadow root, seriously lacking. In fact, if you are doing any work with web components, my recommendation, do it in native JavaScript. Don't use jQuery. It actually hinders the process. It's much easier to work with web components with native JavaScript. The other thing to remember too, there's got to, like, if you know Drupal assigns JavaScript to the document body by default. These web component libraries, they cannot be loaded after content. If you load your web component library after content, you get that flash of unstyled content. So you need to move all of your web component library to the document head. And this can get tricky because you're also writing companion JavaScript that fixes these issues with integration. That does still need to stay in the bottom of the body. So you kind of have to keep that in mind. But when you do move the web component library to the head, it actually improves performance. Anytime you see type equals module on a script tag, that is probably a web component library. Anytime you see type equals module, that script should be loaded in the Drupal, in the head of the document. The other thing to keep in mind too is, even though you have all these accessibility controls with web components, there's still some patterns that trigger not necessarily false positives to the accessibility scanner, but they are, you have to mitigate the situation sometimes with ARIA attributes or role attributes, which you never would have had to do if you were using native HTML, mainly because there's rules for, like, list tag has to be a direct descendant of the ordered list tag. Some of those rules, when you start using web components as lists, you can't do that any longer. You have to start using these kind of like short-term fixes, ARIA attributes and role attributes to kind of get around that. You can build that into your web component, but in my experience, that team typically needs the help of the integration team to realize that. So what to expect and how to fix these issues when you start using web components? The first thing is, there are ways to access the shadow root. You have to go through JavaScript. In fact, you can hack a web component, but you have to use JavaScript in order to do it. You can't just hack it writing a custom style sheet. You can't hack it by adjusting the template because that's fully controlled. But I would recommend, if you do start using web components and you need to fix your functional JavaScript tests that are now failing, you have to write new tests that include a method that attaches the shadow root and then can find the selectors that it's looking for. So there is like a method is in native JavaScript. You just adjust your tests. Instead of just directly looking for that link tag, you first attach shadow root and then you can select the link tag. It does get a little complex though, because these web components also get nested. So if your link tag is, say, 3 web components nested deep, it means you have to select every web component and then attach the shadow root to eventually get into that link tag. So it's a lot of work. This was one of the harder points, was getting our tests to work again. And we did consider at the time using Selenium 4, which does support shadow root, but Drupal has Selenium 2 still. So all of our old tests were still using Selenium 2 WebDriver, and we've tried to get Selenium 4 as a dependency. It's actually harder than you think, considering like there's a lot more work than you would expect. And this also brings up a long-term issue with web components in Drupal. If Drupal 10 ships with Selenium 2, when will we get to Selenium 4? Is that going to be Drupal 11? Is that going to be Drupal 12? Are we talking it's going to be 4 years before Drupal can natively test web components using their functional JavaScript? So this could be a serious gap in our community. I'm hoping that we'll raise some awareness on this eventually and be able to kind of improve on that timeline, because I think 4 years is a little too long to wait to have support for shadow root and functional JavaScript. The other thing to keep in mind, whenever something in Drupal breaks down when you're using a web component, you want to look to the web component for the solution. You don't want to start trying to hack it. So what does that mean? It means that when Drupal's Ajax or Drupal's states visibility is trying to select an input tag, instead you reroute that to select the web component tag. And then you have to use the custom events in order to integrate fully with those functions. But the web component typically will have all the same properties that the tag that Drupal is trying to select and check. So if you just reroute it, sometimes it's a hook. Sometimes you have to write another JavaScript behavior that modifies the existing JavaScript to use the correct selector to find the web component. But in all cases, when it's in the browser, you really want to try and leverage the web component. If you can't get what you need out of it, that's when you talk to your web component team, try and get the events that you really need. And the event listeners is why, so for instance, Drupal states visibility, that breaks down, one, because it's looking for an input tag and it can't find it. So we fix it with a hook. It now redirects, it finds the web component. It can tell if it's checked, unchecked. That works exactly as it used to. What it can't do is know when things are updated or things are input. The default events that exist in all HTML elements, like changed and update and input, like all of these events, they don't exist in your custom web element. They're not there. You know, you don't inherit any of the default events. So instead, your team would have written custom events. So it would be like button change and button input or text input or something like that. And what you need to do is you need to write more JavaScript, and it's essentially a shim where you write a new listener that's listening for the custom event inside your web component, and then it triggers the default browser event that Drupal expects. And when you do that, Drupal states visibility will kick in. You have to fix it in 2 ways. You fix the selector, and then you fix the event listeners. And that's what'll break down. And, you know, always, most importantly, especially when you're dealing with like a really strict web component library for some really important brand, you really want to have a lot of communication with that team. In the past, I've noticed that like local projects kind of expect that they can tweak things Even before single directory components, when it was just copy and paste templates from, a brand documentation style guide, and the projects would copy and paste and alter, right? That no longer is possible. You're not going to be able to tweak every little thing on the page like you used to. So what does that mean? You need to have a communication pipeline open with the team that controls that decision making. And this is actually really healthy for projects, I think. What ends up happening is your web component library will add more support for use cases that make sense. Whereas in the past, without using web components or single directory components, the local designers and local project managers would decide to override certain pieces, and it would no longer be consistent with the brand. So the nice thing is it does add more consistency than ever, but you do need to talk more. You do need to have more cross-team collaboration to produce these web components. But that's one of the key takeaways. And thank you for attending, everybody. Do you want to come back up, Robert, too, in case you got questions? You had a question? Oh, well, thank you. And I didn't actually. I submitted, and I'm hoping we get picked.
See like a large or high time estimate for developing components. I now know where all that time is going.
Yeah.
So with that said, do you have a cheat sheet or guide or process you can recommend for estimating web component development by component?
What was the last part of the question?
Do you have a guide or cheat sheet for how to go about estimating how long it's going to take to build web components?
So currently I do not, but based on experience, I would say 6 months of work, you would have 40 mature web components. And that's in the Node stack. So we're talking Node.js, Lit. Most of the web component libraries, their dependency is on a project called Lit, L-I-T. And then you leverage that in order to interact with the web component API and add the template, add the function, add the styles. But yeah, it takes a good 6 months to have 30 to 40 web components. Yeah. Is there any other questions?
2 microphones, amazing. This was a really great talk, both of you. Thank you. I was very excited to hear about the isolation behavior of web components. I remember 10 years ago when I was doing all kinds of experimental coding, we were trying to figure out how to do embeds. I remember mylifetime.com, the women's television cable channel, hired us to do a quiz portal. And so we had all of these, which desperate housewives are you quizzes that we built out. And then they said, okay, great, that's for our main Drupal site, but we want to embed that across a dozen or 2 dozen other websites, WordPress, Drupal, everything else. And we were trying to embed it, and then we realized we needed iframes or something, which forced it to be fixed height. Mm-hmm. And then I was using weird Chrome messaging APIs that are developed for the Chrome extensions in order to pass messages, resize this iframe to slightly bigger because this content just expanded. Mm-hmm. My knowledge is out of date. As far as you know, are web components the main way to do this now, to have that isolation, or are there other ways of leveraging the same behavior?
So I think the primary way to do that now is with web components. And then the nice thing is that you have complete access to the web component tag itself. So you could actually style, if for some reason on your site, the height is off, you can actually adjust the height of the web component tag. That is styled just like anything else. Typically they're just a wrapper with no styling. But if you had to, you could adjust the height, the width. I've had to at times make a web component in order to do certain layouts. I had to change the add flex or things like that. And that still works the same way. So in my experience, they're actually easier to work with than iframes, but you get the same kind of benefits of isolation. Although it's not as isolated as a iframe is. iframe is a complete isolation on a separate web page. These are still, there still is a way to get inside the web component. You just have to go through the JavaScript layer in order to get there. And it's just, ultimately it's too difficult to even go that direction. It's better to talk to your team to get what you want out of it. But I think it is replacing that same iframe technique. You would now do that with a web component. Hi.
I got one question for Robert. With UI patterns, we used to have a variant, so you could send a variant, and depending on the variant being sent to the UI pattern, we would change maybe the functionality inside the template. Do you have the same thing for SDC? And can you inherit or extend existing SDC?
For the variant of the SDC component, the way that we are using right now is like we extend the component and then override a few features of that. I don't see the same features of the way that we use in variant in UI pattern in SDC yet. So basically, if you have primary button and a secondary button, we would declare the second like two SDC separately and try to inherit them, try to reuse them. Yeah.